XJ-TAG is a global, market-leading provider of boundary scan solutions. Our products are used by hardware engineers around the world in design, development and manufacture to reduce costs throughout the product lifecycle. The XJ-TAG development system consists of three main applications. XJ Analyzer is a graphical debugging application which allows you to interact in real time with the JTAG devices on your boards. XJ Developer is a powerful application that allows you to check connections not only between your JTAG devices, but also your non-JTAG devices. XJ Runner provides you with an easy-to-use graphical interface for running the tests that are exported from XJ Developer. These three products together make up the XJ-TAG development system. When you have ball grid array, BGA devices on a board, fault finding gets very difficult. There are hundreds of connections, all hidden under here, where you can't see them, can't get to them, and can't test them. XJ-TAG can help you see exactly what's happening without lifting the device from the board. The XJ-TAG development system comes with an installation CD, USB cable, XJ-Link 2, and a demo board. The XJ-Link 2 provides the connection between the USB and the JTAG chain. The XJ demo board is used in the tutorials that come with the system. It has two JTAG devices and several non-JTAG devices and will be used in most of the following examples. I've already installed XJ-TAG onto my PC. All I need to do now is connect the XJ-Link 2 to my demo board and plug the USB cable into my PC. XJ Analyzer is a fantastic tool if you're looking to debug a fault with a board. With virtually no setup required, XJ Analyzer gives you a graphical representation of the devices in your JTAG chain. As soon as you start the scan, XJ Analyzer automatically shows the values of the pins on those devices. From the color legend, you can see that red means high, blue is low, yellow is oscillating, and black is for linkage pins, such as power or JTAG connections. If anything causes the value of one of these pins to change, its color will change in real time to highlight that change. If you're working with BGA devices, the lack of physical access means that this is the easiest way to check the value of a pin. You can monitor changing pins in the Pin Watch window at the bottom of the screen. You can also use XJ Analyzer to drive values out onto the board by simply double-clicking on a pin. The pin whose value has changed has automatically been added to the watch window, where you can see, on the right of the highlighted line, that it is outputting. I'm now going to zoom in on the BGA device on the left. Here the pin is connected to an LED. We're now going to set this pin to toggle slow, so you can see the LED flashing on the demo board. It has also been added to the watch window, as we're still monitoring changes on our board. I'm now going to disable that pin. If I set another pin, E4, to toggle, you will notice that D3 has started to toggle at the same time. If you suspect that you have a short under a device, this is a great way to confirm it. Again, both E4 and D3 have been added to the watch window. From the watch window, we can easily locate the pin by using the Go-To function. This is particularly useful on a larger board with many more devices. Setting pins to a particular value, or setting them toggling, is a very effective way of confirming faults or verifying connections between devices. Here we have a board with 8 JTAG devices. The screen can be split to see different views. This allows you to view different parts of the chain at the same time. You may want to scroll down to see the devices further down the chain, or zoom in on one area of particular interest. Now we're going to have a look at XJ Developer, which steps you through the setup process of checking the connections of JTAG and non-JTAG devices. Here you specify the netlist and bill of materials for your board. If you have more than one board, this is where you would define how they're connected together. You can also define connections within a board. In this case, we just need to define this one connection because it is not in the netlist. Next, you need to tell XJTAG which are the power and ground signals. In this instance, there is only one power net at 3.3 volts and one ground net. In the JTAG chain section, you need to specify a BSDL file for each of the JTAG devices on the XJ demo board and how they're connected. In this case, there are two devices, one Altera and one Xilinx. BSDL or boundary scan description files are usually freely available from the chip manufacturers. With the chain defined, you now have access to test both JTAG and non-JTAG devices on the board. Now you can tell the system how to check the connections on the non-JTAG devices, which you do in the Categorize Devices screen. You assign devices into a category until all of the devices are moved out of the unassigned devices list. For example, IC4 is an EEPROM, which has been assigned to the 24LC32A XJE's test file, which was downloaded from the library on the XJTAG website. There are a large number of XJE's files available for download, but you can always create your own files using the library files as a template. Here, you would define any pins that need to remain in a constant state. None are needed for the XJ demo board. Once the setup has been completed, you can use the DFT analysis to check test coverage even before the boards have been produced or laid out. Early design for test information, plus the design verification that is part of the setup process, has saved many engineers from respinning their boards. The summary gives you a breakdown of the test coverage. When you have your board, you need to tell the system how it should be connected to the XJ-Link 2. In this screen, you define the pinout on your connector to match your board and the XJ-Link 2. In the XJ Runner setup screen, you define the tests you want to run on your board. The first test on the list to run is to check the chain integrity. Connection test is an inbuilt function that automatically checks the connections between your JTAG devices. The other XJ Runner tests are to check that non-JTAG devices in the netlist are present and functioning. Finally, you run the tests on your board and the results are displayed on the screen. Once the setup is complete, you can export your files for use with XJ Runner, which is designed to be used in a production or servicing environment. XJ Runner is a runtime system for running the tests produced by XJ Developer. The same tests you've used while designing and prototyping your boards can now be used in production. To save time, multiple boards can be tested simultaneously as a group by using multiple XJ links. Boards can also be tested independently and continuously by unplugging one board that's finished and plugging in a new one whilst tests are still running on your other XJ links. You can view board statistics and fault trend analysis. You can log the results for individual boards by serial number for traceability. XJ Runner comes with different levels of access depending on the user. This is to ensure that only authorized engineers are able to reconfigure the system. XJ Runner can be integrated with other test executives, such as LabVIEW, as well as ATE machines. XJTAG can save you time and money when developing hardware, debugging prototypes, and later in production. To find out more or to take a free trial, contact sales@xjtag.com.